All right, Chapter 7 practice test in the Sullivan book. So the first question is we're going to convert 210 degrees to radians. So we want to get rid of degrees, so we put them on the opposite side of the fraction, 180. That way degrees will cancel. The conversion is 180 degrees is pi radians. So that'll do the work. So I'm going to write 210 pi over 180. If you divide by 30 and you divide by 30, you get 7 pi over 6. That would be the reduced fraction. When you go degrees to radians, you do this fraction. So to go the other direction, you do the other fraction. So it's 5, the reciprocal fraction. So I'm going to multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. 5 times 30 is 150 degrees. Draw the appropriate right triangle and figure out what the answer is. So I'm going to turn around 150 degrees, which means I'm 30 degrees short. You always drop down to the x-axis or up to the x-axis. So my reference angle is 30. The actual angle is 150. Now I label the sides. This is 1, this is 2, this is radical 3, but since it's to the left, it's negative radical 3. So side opposite 60 is radical 3, 1, and 2. Now you do y over r, 1/2. X over r, negative radical 3 over 2. And tangent is the slope. It's y over x. So it's 1 over negative radical 3 or negative 1 over radical 3. All right, next one, 225. So I'm going to turn 225 degrees. That's 180. So I'm going 45 past. Up, always up or down to the x-axis. So my reference angle is 45 degrees because I went 180 and then 45 past. 1, 1, radical 2. Again, left is negative, down is negative because x is negative, y is negative. So those have to be negative. Otherwise, you're not going to get the right answers. X and y are positive here. X is negative, but y is positive. X and y are negative. X is positive, y is negative. So you got to pay attention to what quadrant you're in. Okay, sine y would be negative 1 over radical 2, y over r. Cosine is the same answer, negative 1 over radical 2, because it's x, because x and y are the same dimension. And then the slope is, see how it's a positive slope? Right? If you're thinking about your circle here, that radius is positive and a positive slope, so it's negative 1 over negative 1, which is just 1. All right, that's the first page. Page 2, 300 degrees. That means I'm 60 degrees short over here, so this is 60 degrees. So I go around 300, 60. This would be radical 3, and this would be 1, and this would be 2. And again, positive, but this is negative, so that's a negative direction down. So we do the same thing, the y, the x, all that business. So y is over r would be negative radical 3 over 2. X would be 1 over 2. And slope, this time the slope's negative, so it's radical 3 over 1, or just negative radical 3. 30 degrees is the easiest one of them all. It's right there. It's 30, it's 1, 2, radical 3. Sine of 30 is 1/2. Radical 3 over 2, and 1 over radical 3. It's in the first quadrant. Everything's positive. Okay, now some different properties, identities, trig identities. It's everybody's favorite topic. And the first one that's coming up here in A is the complementary angle, right? So if you have two angles that add up to 90 degrees, these two angles are complementary. So you have angle alpha and angle beta. So alpha plus beta alpha plus beta is equal to 90 degrees, and that makes them complementary. Supplementary is 180, complementary is 90. So we learn in this chapter that this is the sine of 22 degrees. So if you add those together, you get 90. So the complement, the sine of the complement with the cosine, it makes it the same. So this minus this is 0. Sine squared plus cosine squared, so sine squared of an angle plus cosine squared of an angle is always equal to 1, as long as these are the same angle. So 13 degrees has nothing to do with it. It could have been any angle there. It's just sine squared plus cosine squared is equal to 1. Okay, reciprocals. S goes with C, C goes with S. So we learned that cosine of 40 is 1, and then secant, it would be 1 over cosine of 40 degrees, because secant and cosine are reciprocals of each other, so 1 over cosine is secant. And then this means we get cosine of 40 degrees over cosine of 40 degrees, which is just equal to 1. And sine over cosine, again, these angles have to be the same. Sine over cosine is tangent, so this is tangent of 18 degrees minus tangent of 18 degrees, which is equal to 0. Same thing minus the same thing is 0. So I don't need to know the tangent of 18 degrees, I just need to know that it's the same as that. Okay, question number 5. I've asked you to write out several ratios. So this time I'm just asking you to draw the reference triangle and label it correctly. So draw and label the following reference triangles for the given angles. So 600 degrees minus 360 means that I have 240 degrees left. So 360, I've gone one trip around. Minus 180 is 60 degrees. So I'm going around one trip, and then I'm doing 180. So that lands me right there, and then 60 degrees past. So I'm doing 60 degrees past, which makes this 30. Side opposite here, negative square root of 3, negative 1, and 2. I believe I drew that one already. Did I not? 150, 300, oh, close to it. I did 300. It's the same as this one, it's just that's negative and it's flipped over here instead of there, but it's about the same. I don't ask for the sine, cosine, and tangent of it. I just ask for this to be drawn, because then it's like, you know, it's the same thing over and over again. Y over R, X over R, Y over X would be the sine, cosine, and tangent of 600 degrees. And of course, secant, cosecant, and cotangent are, you know, just the reciprocals of sine, cosine, and tangent. So once you know one, you basically know the others. Okay, this is 45 degrees. We've done that enough times, and it's negative, so we're going this direction. So it's going to be, it's 45 degree angle is my reference angle. Negative 1 because it's down. Positive 1, radical 2, and that is done. So I'll make it the 90 degree angle there. 135 means I'm going 90 and then 45 more. Remember, it's always up or down to the x-axis, so it's 45. Negative 1, radical 2. I feel like I've drawn that one recently. Did I? Yeah. That's the same as this one right here. Okay, the next one is 2. Goes in there 2 times with 1/6, so it's 2 and 1/6 pi. So it's 2 pi plus 1/6 pi is 2 and 1/6 pi. So 2 pi is all the way around, and 1/6 of the pi more is just 30 degrees. This pi over 6 is 30 degrees. So it's going to be 1, 2, radical 3, and there it is. Make the right angle. Perfect. Beautiful. Okay, and the last question. These are, all of these land on the x or y axis. So 0 is here, which is also 2 pi. Pi over 2 is here. this would be pi, this would be 3 pi over 2. And that's what all of these are, is that they're landing on the x or y axis. The only one I have on here is pi. So when you land here, x is 1 and y is 0. When you land here, x is 0 and y is 1, because the radius is 1. So we got this circle going on here. So we got circle, 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 circle. So then this point here would be -1 comma 0, and then this one right here would be 0, 0, -1. So we know what x and y are for all of those positions, and then r is 1 all the way around. So basically we know what to do. So here we are. So boom, boom, boom. That's 2 pi. So x is 1, y is 0, r is equal to 1. So once you know that, you can do sine, cosine, and tangent. So it's y over r. So it's equal to 0. We also know that the sine curve is a mountain followed by a valley. So therefore, 2 pi is the period. So 0 to 2 pi, boom. That's the answer also, because boom, 0. Okay, so this one is 270 degrees. So it's down here. 0 comma -1, that's your x and your y, and your r is equal to 1. So the sine is y over r, so it's -1 over -1, so the answer to this one is -1. Okay, you can also look here at the sine curve, so that's right there, and it's down at -1. Cosine. Cosine curve, if you can do it that way, it's a half mountain, a full valley, and a half mountain. So the cosine of 0 would be 1. The cosine of pi over 2 is right there, and that would be 0. Okay, so those are the answers for that. But you can also think about it in terms of the circle. Here's the circle. 90 degrees is right here. 0, 1, that's your x and y. And then your radius is equal to 1. So cosine is x over r, so it's 0 over 1, which is 0. 0 degrees is right here, right? So it's 1, 0, that's your x and y, and your radius is equal to 1. So it's x over r, so it's 1 over 1, which is 1. So that's another way to think about it, or you can think about the graph. I think these are really, when I'm doing this quickly, did I label them correctly? 1, 0, 0, -1, that's right. 0, 1, 1, 0, and did I label all these right? 1, 0, 0, 1, -1, 0, 0, -1. Yes, those are labeled correctly. Man, when you're going, it's like, it's easy to get it backwards. Okay, tangent. Tangent is slope. It's the slope ratio. So here's 0 again. I just drew this. 0's right here. And I got 1, 0. That's your x and your y. And your r is equal to 1. So it's y over x. Tangent of 0 is equal to 0. Also the graph. Tangent blows up at pi over 2 and -pi over 2. Boom, boom. So at 0, it's 0. Okay, this one is down here, 3 pi over 2. And that is 0, comma -1. And then that's your x and your y. And your radius is equal to 1. So then it's y over x. Well, y over x would be -1 over 0, so that's undefined. Okay, so that makes sense, because if you continue on, the next time that the period for tangent is every pi, so the next time it blows up is pi later, so a half pi, 1.5 pi, which is 3 pi over 2. So it's going to blow up here, so it goes, So it makes sense that it blows up at 3 pi over 2 just based on the graph of it. All right. Also, if you think about the radius here, the radius is straight up and down, so tangent slope, so that's undefined. Here the radius comes across left and right, that's a slope of 0. So slope makes sense as well. All right, 15 minutes, ba-boom.